science teacher. Okay, this afternoon we'll be looking at the topic radioactivity. By the end of this lesson, we're expected to know these specific objectives. 1. We're expected to be able to explain the meaning of radioactivity. 2. Name some radioactive elements. 3. List the 3 types of radiation and state their properties. And lastly, the 4th one, state the uses of radioactivity. Okay. Before we go into the topic proper, I would like to give a brief history of the phenomena radioactivity. This phenomena radioactivity was discovered by a man called Henry Becquerel in 1896. Here is the spelling of the name, Henry Becquerel. I said that the man that discovered radioactivity is by name Henry Becquerel in 1896. He carried out some experiments that shows uranium giving out some kind of particle that will penetrate through thick black paper and affect a photographic plate placed at the other side. This process is called radioactivity. So, this man was the man that discovered that some elements, when they are left on their own, they begin to disintegrate. And man was able to find out that on the course of that disintegration, they emitted something that we call a particle or a ray that could affect another element. So radioactivity simply means is the spontaneous decay or disintegration of the nucleus of the atom of an element during which it emits radiation. You can also call radiation particle or in the word ray. Some of the radioactive elements, it's not every element that can emit this particle or radiation we are talking about. We have some elements that does that. And some of the elements are uranium. Remember that I said that the founder of this uses uranium to observe that some elements emit radiation. We have radium, thorium, radon, and plutonium. So these are some of them. Then the radiation emitted are of 3 types. We have the alpha, represented by this symbol. Then we have beta, represented by the symbol B. Then we have gamma. These are the 3 particles that is usually being emitted by radioactive elements. Remember that radioactive elements are those elements that are able to decay to emit radiation. Now, the 3 particles or the radiation, when passed through different material, they have their penetrating power. The alpha, when you pass it, the alpha particle can not pass through a sheet of paper. So it has a small limiting penetrating power. But the beta particle can pass through a sheet of paper but cannot pass through an aluminum paper. While the gamma particle can pass through a sheet of paper, aluminium, but cannot pass through a lead or a concrete. Then when you place this radiation also in a magnetic field or electric field, there is always a diffraction. Look at it here. This is a radioactive element here. Radioactive element placed in a magnetic field. This is a magnet. You will find out that the emitted particle, the gamma, the one that went straight, is the gamma particle. You will see that the alpha particle was deflected to the north pole, to the south pole of the magnet, while the beta particle was deflected to the north pole of a magnet. So when you place radioactive element in a magnetic field, electric field, there's always a deflection, but it's only the gamma particle that is not being deflected. It's not being affected. So from there, we'll now look at the properties of these radiations or particle emitted by radioactive elements. Now we look at the first one, the alpha particle. One of the properties is that it can travel a short distance in the air. Then number 2, say that it has little penetrating power. Number 3, the particles are positively charged. Number 4, are deflected by electric or magnetic field. Then number 5, have a mass equal to helium nucleus. Remember, in the element table, helium is the second element. Then let's look at properties of beta particles. It is negatively charged. 2, penetrating power is intermediate. That means it has more penetrating power than the alpha particle. Number 3, it is deflected in the opposite direction of the alpha radiation. From this diagram, you will see that the alpha radiation is deflected to the north-south pole, while the beta is north pole. That is opposite. Then the fourth one have a negligible mass when compared with alpha or gamma ray. Then properties of gamma ray. 1, it gives out electromagnetic waves. The particles have a short wavelength. 3, have no charges. That is, it is neutral. Have the greatest penetrating power among the 3 particles. If I may take you back to their penetrating power, you see that it was able to penetrate through paper, aluminium, then lead to some extent, then stop. So that is why they said it has a greater penetrating power. Now we'll now go to the uses of radioactivity. The uses: 1, it is used medically in treating cancer. It is used to monitor and control the thickness of sheets material used in the industries. 3, it is used for sterilization. That means to kill germs, and also for sterilizing surgical equipment in the hospital. It is also used in agriculture for improving soil content. 6, it is used for production of bombs. This is the negative effect of it. Then 7, it is also used in carbon dating by those that study ancient materials. Then lastly, it is used as a marker or tracer to find out what happens to elements during chemical reaction. With this, we come to the end of today's lesson.